P300?
P300 is our algorithm design and problem solving class.
You know, surprisingly, that doesn't transfer over to National University's algorithm design and problem solving class.
Well, transfer to what over there?
It doesn't transfer
at all.
Yeah.
But what do you think? But what do you think it should transfer to?
The algorithm design.
Do they have a class like that before the C class?
It's the same. It's the same. It's the
content?
same. Yeah, it's the same content.
Did you check? Because different colleges have different
yeah, they have
transfer.
They have a list with all the community
colleges. So none of
colleges.
our sister colleges would transfer that
No.
class.
You might check CSU, the first transfers to CSU and CSU transfers there. That we can make a good argument with them.
But CSUs don't even have a pre-programming class that I know of.
Oh, that
I know
algorithm
UC
pre-programming?
Yeah.
Well, maybe it's a different. I didn't look at the course material. It's the same name of the class, but it might be different material.
All right. So, did you guys get the homework assignment done? Was it?
Finally.
Well, other than the misinformation that I gave you guys, what was the main challenge of the homework assignment? Was there a main challenge?
The bitwise operation.
Bitwise operation.
But
okay,
that was
that's
so
new.
cool once I figured that out.
Yeah, exactly. They will be useful throughout this class, because a lot of low-level access require on bitwise operation.
The main challenge is finding stupid mistakes.
And how to debug programs too. I think that's one thing that the first two homework assignments is to get you guys back into the programming mentality of okay, now that my program doesn't work, how do I know where it is not working and how do I make it work again? Okay. Any other questions? No other questions? All right. All right, so it's too late to turn in the homework assignment for this one anymore. But do you guys want to see how I do the program, or do you want to kind of move on?
I'd like to see it.
Okay. Sometimes the way I do it confuses people more than explaining things. So it all depends on how. All right, so I'm going to start with this document and then open it in a new tab. This is, by the way, Google's own PDF reader, which works okay. I don't have any complaints. All right, so we'll go ahead and just write that program. Make a folder for today, 2012-02-13.
Could you show me how to save something in Vim with a file name while you're doing that?
How do you save something in Vim?
Like if I just type in Vim, it doesn't, like without a parameter as a file name. How do I save that file?
:W and then the file name.
Okay. All right, thanks.
I can do exactly that. So I just go. I will go into Vim without specifying the file, and then I can type something like county include UNISD. That's the only header file that I need for open. I don't even need to open. This is only for the read call, and also put as. Now for put as, I need to use stdio. So I got a little lazy and just use a printf instead of all my own subroutine to print in decimal and hexadecimal. And turn on syntax highlighting and automatic indentation. All right. With this program, there's no need to read the parameters passed to your C function or the main function. So I'm just going to leave it as void since I'm not going to do anything with the parameters passed to main. Specify return 0 at the very end, and then now I'm ready to insert content. The first thing I would do is to read the notes again, read the homework assignment. All the requirements are here, so I would read the homework assignment carefully just to make sure that the program is going to do exactly what is expected here. Okay, the program should read 512 bytes from standard in. Okay, so this part means you don't have to open up a file called mbr.bin. You just read it in from standard in, which is file descriptor 0. So that's exactly what I would do. Now, remind me again, where did I talk about standard in is file descriptor 0?
Like the second class or something.
The first homework assignment has it too. The first homework assignment reads from standard in and it writes to standard out. So that's when we first talk about file descriptor 0 and file descriptor 1. So in this case, I will read from file descriptor 0, and There are two ways to do it. Since all I really care is can I read 512 bytes. If I cannot read 512 bytes, then something is not right? So I don't really need to do much else other than this. So I would say, use a buffer here, and it is more convenient to use unsigned to begin with, but you can use, just regular char. You just have to deal with the signed, extension part later on. But unsigned char means you don't have to deal with signed extensions after that. So it just, it's just, handy. Now here I have a choice. So when you're programming, there are many choices at many different points. If you realize that you have choices, it's already good, because that means you're already thinking about, okay, how should I do this? If you don't realize that you have choices, then you should probably take a look at other programs that people have written, professionally written programs, and then see how other people do it. So right here, I could just write down 512 here and say, okay, in the homework assignment, I said very specifically to read 512 bytes from standard in because that's the size of the MBR. But in terms of programming practice, it's not a very good practice to just write down 512. That's because later on when I use the read instruction or the read function call here, I will read from file descriptor 0, standard in, and then I will read into the buffer. And here, I can just say that and then compare the end result or the return value to 512. This will get things done already, but it's not a very good approach to do it this way. Oh, no file name, so this will answer your question. So write, and then you give it a file name, mbrviewer.c, and now the file is written as mbrviewer.c. Okay, but this is not a very good idea because I'm basically scattering these constants all over the place. So that means later on, if I want to change the program to read an MBR that is not exactly 512 bytes, or I realize that I might have made a mistake. Let's just say that I misread my own homework assignment and use 256 bytes instead of 512. Okay, that's entirely possible, especially when you're working with a much larger project. You use the wrong constant. It's not a problem. The mistake itself is not the problem. The problem is when you're fixing that mistake, is it possible that you will only fix a certain part of your program and not every place that you refer to that size? In this case, if I make a mistake and you refer to 512 as 256, then I will have 3 places to fix. If I forget to fix one place, the compiler is not going to say, hey, I think you meant to fix that one too. Okay? So this is not a very good approach. What I really should do is to do something more like this. Pound define MBR size as 512 bytes. Okay? Then everywhere I refer to 512, I would replace it with MBR size. Oops, I forgot to specify the G, so it only replaces one and not the other one.
So say if your master root record was 4 kilobytes, like you said earlier, so using a define, we could actually specify that on the parameter list, right? Like we can change the MBR size on the parameter list when we're running the file.
That is correct.
So we could actually output like a shell command that would give us the whatever the master root record size is.
That is correct.
So we can make it universal.
That is correct. But that's actually not the case because you only have one size for the master root record. But I'm using this as an example of try to avoid the use of literal constants and instead use either pound defines or use constants. Yep.
I've heard that using constant chars for instead of pound defines, like that might be better. But what do you think about that?
So you're talking about something that's more like this, const unsigned and MBR size equals 512.
Yeah.
It depends, personally I use pound defines, unless I know I have to refer to the address of this, then I would use a const definition in that case. Yep.
Isn't the difference that MBR size as a pound define would get translated into literal 512 and then compiled without taking additional memory, but it would not be accessible as a symbol at debug time or at runtime?
That is correct. It's a C preprocessor concept. So that means by the time it passes to the compiler should only see 512 and not MBR size. That is correct. So that means when you're debugging, you can no longer refer to MBR underscore size. We can try that. I'm not sure how smart the compiler is, whether it can spill out certain things like that and make the debugger still understand some of the macros. I really doubt it because it's called a preprocessor concept for a reason. But we'll give it a try, okay? And we can define both, so that we can have the other one too. But the main idea is you should use a symbolic name instead of the actual numerical constant. That's one thing that can save you a lot of trouble down the line. All right. So right here, someone asked me in the lab, whether if you check and the program is not doing something correctly, can I just put a return somewhere in the middle of the program and just exit out early? The answer is yes, you can, because the C programming language allows you to specify the return statement anywhere you want. And unlike in Pascal and also Visual Basic, where when you assign a value to the name of the subroutine, it doesn't actually exit the subroutine, it just remembers the exit code or the return value. In C, when you say return, it does two things instead of one. One, it specifies the return value, and two, it actually gets out of the subroutine and return back to the caller. Yep.
Can we call int main?
Can you call int main?
Yes.
Yes, you can.
Oh, really?
Yeah.
Oh, that's interesting.
Yeah. Although, it does make it kind of difficult to track the recursion, because main takes argc and argv, but you have to you can make this main so that it can recursively parse, argc and argv by, changing those two parameters. But the value of doing that instead of a loop is very minimal. I mean, you're not really gaining anything by doing that.
Do you have to use a function pointer?
No, you just have to. You have to decrement argc and increment argv every time you do a recursion until argc becomes 0. Then you know that you have parsed all the parameters. But I really don't see any value of doing that. Simply because
It's cool.
All right. But the point here is, I don't really specify any return inside the conditional statement. When I'm not reading in what I'm supposed to read in, I go back to my homework assignment, and it says right here, okay, if we are not reading at least that many bytes, we can say it is reading too small. And I don't have to check whether the file is valid or not. There's no, nothing here that says you have to check the validity of the file. So I can just use put string, and then say MBR too small. And when you use put string, there's no need to put a \n at the end, because the line feed is automatic with put string. Okay. Any questions at this point?
What's actually put a string?
That's put string, which means it prints a string, whatever
But
you
will
specify.
it use the string class?
No, this is just a char array.
Oh, okay.
Yeah. Okay. So in this case, I can continue to specify the rest of the program. Ignore the first 440 bytes, which are designated as the code area. You can use object dump if you're curious of what's there, but you don't have to do anything like that here. Check the Mbr signature. So now we have to look at the Mbr signature and find out where the signature is located. And it's exactly the term Mbr signature here. Let me magnify so that we can see this portion a little better. I think the middle mouse, yep, scroll works too. Cool. All right. So this tells me that at offset 510, I should see the byte 55 in hexadecimal, and at offset 511, I should see the constant AA. Those two are specified in hexadecimal, and they are basically bytes. There are two ways to do this. You can check these bytes individually, or you can check them as a whole. Now, because I have already read everything into memory, I can pull a certain trick to deal with this, with a single comparison. So I'll go ahead and show you what the trick looks like. I already told you, how to do it in class last time, using the shift operation and using the bitwise OR operation. So that you can take the most significant byte, shift it 8 times to the left, and then OR it with the least significant byte. That's one way to do it. But the second way to do it is to rely on the fact that both the MBR and also the Intel processors, they're both little endian. They're both using the little endian standard. So we can do a trick like this one here. Okay. The next step is to check the signature of the MBR. So once again, even though it really is not necessary here, I would still do it like this. Okay, just so that when I read my own program, I don't have to ask myself 3 months later on and ask myself, what is at location 510? Well, if I use the macro name, signature offset, or if I define a constant, for that purpose, it will still serve the same purpose. In other words, I'm trying to make my program as self-documenting as possible. Okay? There's no such thing as a truly self-documenting program, but you can improve the readability of your own program just by changing the use of constants or literal constants like numbers into names that actually has some meaning to it. Is that making any sense?
Are you going to use that for your masking value as well? Are you going to do pound define?
You can do pound define, or you can use const. Either way is fine. I think most people now recommend the use of const whenever that is possible, and pound define can do some really weird stuff that const can never ever do.
Put a semicolon after the number.
Oh, you can put anything. Yeah, it's just expanding the text. You can do string concatenation using macros, and you can do a lot of tricky stuff with macros that const cannot do. But if you're just defining constants, const would do just fine. Okay, and if you don't like the word, the use of underscore and all uppercase, definitely switch to consts. So let me just do that. Let me switch to constants, from here on. The other thing that's nice about const is it also has a local scope. In other words, it obeys the same scoping rules as all local variables. So you can define, a const of the same name in different subroutines. But macros are global. Okay, so once you define a macro, it is visible from that point on. The other thing about macros is you can also undef. You can undefine a macro and then redefine it to something else, which can cause massive confusion, for people who are not used to it. So anyway. Here we go, signature offset equals 510. Now, since this program is only dealing with MBR, it is probably okay to say, this is signature offset instead of MBR signature offset. On the other hand, if you're writing a program that can be dealing with MBR and also the super block and stuff like that, these may not be sufficient because you don't know whose signature offset we are talking about. Now, the other thing that we can do to help this a little bit is to move the scope. So now these two constants are no longer globals, they're now local to main or whatever subroutine that has to deal with this. So
How did you do that? How did you move them?
2DD and then Y.
2DD, then what?
And then Y.
Y?
Y for yang. Y for 2DD and then P for paste. Sorry. My fingers knows the answer, but my brain does not.
That's cool.
Yeah, VI is all about muscle memory. It's not. All right. So here I'm going to pull a trick, to do the comparison of the signature bytes. The trick looks like this. Okay. So I'm going to compare whatever is inside the parentheses to the constant. Let's see. The most significant byte is AA, so when I spell it out as a 16-bit number, it's going to be AA55. Okay? So you can see that I use exactly the same structure here. If the signature bytes are confirmed, I would go ahead and just do a message here to indicate that I found the signature bytes. MBR signature confirmed. So I'll just go ahead and paste it here. MBR signature confirmed, just like that. Oops, wrong place. Okay, there we go. And then here I have to actually do a printf, and I'll deal with that later. Now I have to get back here and find out what the signature really was. Now, since in the printf statement here, I'm supposed to print out what the signature really is, the bit pattern, even though it doesn't match, I have to say what it is. And here, where the cursor is located, I have to compare the same value. It makes sense that I want to make a local variable so I don't have to recompute the same value twice. Is that okay? Okay. So what I want to do is to define my local variable here. And in this case, I'm going to use un16_t to really mean that I'm dealing with a 16-bit unsigned integer here. That's not a usual type in C. It's not a built-in type. You actually need to include stdint.h in order to make use of that.
What's the difference between that and an unsigned short?
It is platform dependent. Unsigned short would do the same thing, but that's an assumption. And to someone who doesn't understand the standard or the convention that unsigned short is also a 16-bit unsigned integer, that may not have any meaning, because as we move on to larger and larger architectures, the default of short may or may not remain as 16-bit. Does anyone know whether C99 actually defines short to have to be 16-bit long or 16-bit wide in this case?
I don't think it does.
Yeah, if it's not defined in the C language specification itself, that's subject to change. It depends on the compiler. It also depends on what flags you pass to the compiler. But if I do it this way, that means there's a header file, in this case stdint.h, that is already being platform dependent, and it will define uint16_t to mean exactly 16-bit wide integers. So that's why I would like to leverage someone else's research and work so that I can always refer to the right width. Yep.
I'm pretty sure shortend is declared to be whatever half a word is in your architecture.
Okay, but a word can change, because if you say int in the 64-bit architecture, and int is 64-bit automatically, so that will make short a 32-bit. Now, in those particular cases, I think you can say short to mean 16-bit, because every time you say short, it is halving it, if it is using that particular rule. Because when you say long in this environment, when we have a 32-bit processor, long is the same as regular int, which is 32-bit. But when you say long, then it is a 64-bit. So when you have a 64-bit platform and you say long, it probably means 64-bit to begin with. When you say long, it would mean 128-bit. So that's why I personally just like to use these defined types, just so that I don't have to think about it. And once again, it is quote-unquote self-documenting. Okay, because when I say something like this, that reminds myself that I'm dealing with a 16-bit quantity here throughout the rest of this code. So I'll just call this signature. Okay.
How do you feel about sprinkling your declarations throughout your code as opposed to blocking them all out at the beginning?
I would only I make my variables to only have the narrowest scope necessary, so that I don't have to worry about reusing a variable incorrectly somewhere else.
But how about that you put it there rather than putting it up on the top with everything else? I mean,
I should also do this too. To play by my own rules. I would also do this. It's part of that is programming style, and part of that has to do with who else need to have access to these constants. For this homework assignment, I know that only this part of the program really needs to refer to these constants. So I try to define my constants and my variables as close as possible to where it is actually used. On the other hand, if you're writing let's say a library or a header file, so that many other people can use the same constants without having to redeclare the same constants again, then yes, in that case you will have to clump it all together, not only to move it to the beginning of the definition, but because you're defining a .h file, they all have to all the externs must be in the .h file when you define the .h file. But in this case, since this program is not intended to share any of its code with anybody else, so I can kind of do it this way. Yep.
So where you're declaring those, is that actually smaller in scope than if you declared them right after your left brace in main? Is it smaller in scope?
Yes, it is now smaller in scope because the scope would only go from this open curly
thank
brace
you.
to the end of that curly to the end of that curly brace. Yep.
Why is it that they say you should never use global structures or global variables?
Because they are evil.
But why? Everyone tells me the same thing.
Okay, well, no, I know we are digressing from this, but I think it is still a valid discussion because there will be many other programs that you have to write in this class, and there will be times that you'll be tempted to use global variables. And let me try to answer his question first before we come back to this one. Go ahead.
I was just gonna say, I like declaring variables in the lowest scope, closest to where they're used.
Mhm.
It's kind of more self-documented as well.
Yep.
Easier to understand.
Yep. Because otherwise you end up with a whole bunch of definitions all the way to the top, but since the definition itself is so far from where it is actually used, even if you document at that point, it doesn't really connect to the actual use of the variable when you're actually referring to those variables. Now go ahead.
I was just gonna say there's also an argument to be made from optimization. By declaring the variable lower, it doesn't allocate memory and all that stuff. So it's less.
The compiler has the option to allocate late, to take up stack space as late as possible. And then if you have two scopes that are parallel, that are next to each other, same level but not the same, they're not embedded, then the local variable space of one can be reused for the other scope. The compiler has a choice. I mean, that's up to the compiler to decide whether to define an allocate space for everything at the beginning, or whether to continue to kind of allocate and deallocate space as you enter and exit scope. But the compiler has the option in that case. If you put all the definitions at the top, then the compiler doesn't even have a choice in that case. Well, it actually does because it can analyze how a variable is used, but most compilers probably won't even bother with that. Getting back to global variables. Global variables are evil because they can cause problems, or they can have, everybody will write some faulty logic at some point. That's a given. So the question of whether you write good programs or not is not whether you have problems or you have defects when you write programs. I write buggy code all day long, and you guys can read the standard output of my the sample output of my program and see that, oh, okay, the attack is wrong here and also here. So I make mistakes all day long. The question is, can you locate those problems quickly and be able to fix those problems reliably every single time? If I want to put it the other way, for every bug that you fix, how many bugs are you introducing? That is the question. Okay? If that ratio is like 0.2, for every bug that you fix, you introduce 0.2 bugs, you're doing pretty good. Okay, I think the industry standard has a pretty high number. Okay, now if you use global variables, the ratio can be, for every bug that you fix, you introduce 1.2 bugs. Okay, in other words, the bug count actually increases as you start to fix things. And that's because with global variables, they're accessible everywhere. The prototype of the function does not say that this function needs this thing to work. It's just a global variable. So every function is a suspect. Okay? Now, if you look at it from the flip side, let's say you have a program that's almost perfectly working. Okay? And you're just adding one more feature to it. And then you say, well, I'm going to use that global variable as a flag to indicate that I need to da-da-da-da-da. Okay? But guess what? There are 20 other subroutines using that global variable for some other reasons. So by introducing that feature that you wanted to introduce, you just broke the other 20 subroutines.
Okay.
Are you starting to see how it can be very evil?
Yeah.
Yep. And it's all for the sake of convenience. That's the worst part of it. I don't want to add one more parameter to my function, so I'm going to use a global variable for that purpose. That's usually the first excuse, okay? And it's just not worth it when you have a program that will grow big and multiple people will have to, co-develop at the same time. Global variables are really bad news for anything, even like that.
Thank you.
Mm-hmm. Sure. All right. So continuing, getting back to the trick that I was about to show you guys. Okay, the trick is typecasting. Okay, so when I do typecasting, I'm going to cast, something, dereference a pointer. In other words, I'm trying to cast a pointer which natively in here is a unsigned char pointer. I'm going to cast that pointer to something else before it is dereferenced. Okay, so inside, inside here, I'm going to first specify the, wrong place to put it. Okay, two more things. The first part here specifies the type, and I'm just going to say that I will cast the pointer to a 16-bit unsigned integer pointer first. But what am I casting to a 16-bit integer pointer? Well, it's going to be a buffer plus the offset to the signature itself. So in this case, it's signature offset. So that is what I'm going to do to compare the signature bytes, the 2 bytes, to AA55 as one single expression. Yep.
Do you mean uint16_t, not uint_16?
Oh, that's right. That's what I meant when I say that I introduce bugs all day long in my programs. But this one is an easy one because the compiler will find it and go like, hey, don't understand that. That's an easy one to fix.
Unless it's an actual valid
Type.
It doesn't do what you want.
Yep, that's true.
Now, don't you want to do most of that casting on the line above?
The line above.
Where you said the signature?
Oh, you're right. Because I wanted to use the same expression. This is where VI comes in handy. Because now I can find out where I want to finish the copy and paste. So I'll just go for and then paste it up here. Give it a semicolon at the end. How's that?
Awesome.
The VI editor really gives you a lot of options. I did everything without using the mouse at all. And when you learn how to do it, it just comes in very handy. Yep.
What does that asterisk do? Or
This one?
No, the other one.
This one?
Flat. Yeah.
Well, let's take a look at this expression here and find out what it does. Okay. Yeah. Go ahead.
Do you have to make the signature variable pointer?
Nope. It's not a pointer because there's a final
Oh, you're
dereference here.
dereferencing. Sorry.
Yep. In other words, I introduced one level too many parentheses. I can just get rid of that one too. Okay. That makes it easy to read. All right. So let's take a look at this expression and find out what it does. Let's start with this side here. Okay. Let's start with just buff. What is buff?
It's an array.
It's an array of chars. Okay. But I can also use it as a pointer. Okay, it's an address. It's, to be more specific, it is an address. But the address in C has a type. The type in this case is a unsigned char. So what happens when I say add a particular constant to it?
You advance the
You
pointer?
advance the spot in the array.
So the expression is now pointing to sig offset bytes or chars after the beginning of buff.
Yeah.
Okay? Which is still a char pointer, by the way. It's still an unsigned char pointer at this point. Okay? But it's pointing to the first byte that I want to access, which is going to be the 55. Is that right? Okay. So that defines what this whole thing is, inside the parentheses. If you put a type in parentheses before a value in an expression, it's a typecasting operation. In other words, I'm changing the type of this item here to something else. Certain things you can cast and certain things cannot be casted. In this case, casting the type of pointer to another type, of a pointer to another type is okay. You just have to know what you're doing. Is this a good thing to do? That's the question. All right. So what is this? What is this part specifying? Just the highlighted portion. What is that?
The type.
It's an integer type. It's an unsigned integer. It's an unsigned 16-bit integer type. What does it turn into when I use an asterisk after that?
Pointer?
It becomes a pointer to an unsigned 16-bit integer. So that means I am casting a unsigned char pointer into a unsigned 16-bit integer pointer. So by the time I do the dereference, what does it see? What is inside the overall parentheses?
And that's when 16-bit.
It's a 16-bit unsigned integer pointer.
Pointer.
So when I dereference, it is now treating that pointer as a pointer to a unsigned 16-bit integer. So when I dereference, I get a 16-bit unsigned integer, and that's perfectly fine because signature itself is a 16-bit unsigned integer. Yep, go ahead.
Why are you not just dereferencing and then casting? Why don't you just dereference buffer plus sig offset? And
Because
then cast?
when you, as soon as you dereference, it uses the type of the pointer to do the dereferencing. So if you dereference first, then it will become an 8-bit or a unsigned char. From the unsigned char, yes, you can cast it to a 16-bit integer, but you would have lost the most significant 8 bits that you wanted to access to begin with.
Got it. Okay, thank you.
So that's why you have to cast the pointer first and then
Then
dereference
dereference
it.
it. Thank
Because if you dereference it first, then it would not have accessed the most significant 8 bits to begin with.
That makes sense.
So when you cast it again to a 16-bit, you're just sign extending it. In other words, you're just
a bunch of
padding
zeros.
zeros in that case.
Thank you.
Yep. Yep.
So by doing it this way, then you only have to deal with one piece of data. It's going to grab all 16 bits. Otherwise,
Correct.
you'd have to grab the 8 bits, mess with it, grab the next 8 bits.
Correct.
And how is it grabbing all 16 just because you're using a pointer?
Because I'm using a pointer to a 16-bit integer.
So it's looking for 16 bits.
Right.
Change the type.
Yep, because I changed the type of the pointer.
Okay. Thank you.
Is it zero filled?
It's not filled by
No.
anything.
No.
I'm grabbing 2 bytes from the array and tell the compiler and say, treat these 2 bytes as if it is a single 16-bit integer. That's what it's doing.
So just so I understand what you're doing, if you had cast it to a 32-bit unsigned integer, you would have grabbed 4. I know we're at the end of the array, but
Correct.
you would have grabbed 4 bytes.
Yep.
Okay, thank you.
In fact, if
You
I
still grab 4 bytes, just not what you think
Right,
you're grabbing.
right. Grab
now
something.
if I did something like this, it is still valid syntax, and the compiler would actually still compile, but it will give me a warning. Because in this case, I have the entire right-hand side becomes a 32-bit integer, but the left-hand side is still a 16-bit integer. And in this case, is an implicit demotion. And the implicit demotions are either reported as errors or it is at least a warning, because the C compiler says you're losing precision. There's no way you can fit 32-bit in 16-bit. So there's no way this can be automatic.
Makes sense.
But when it is casted to 16-bit, then the 2 sides are exactly the same width, and there's no problem from the compiler. Okay, so in this case, I have to report an error, and if I look back to my notes here, the error is supposed to be invalid Mbr signature, blah blah blah. Okay, so in this case, I'm going to cheat. Just use printf. Okay, invalid Mbr. Invalid Mbr signature. Now you have to start with a 0x, okay, because the 0x is a part of the thing that you have to output. Yep.
So would this work for a big endian system?
Would it work with? No, it would not. That's a very good question. I will explain why in just a little bit here. Now in this case, the \n is required because printf does not automatically end a line with a line feed, but put s does. So in this case, you have to put a \n at the end of the string, and I can just give it the same thing as my signature, and be done with it. Are there any questions? Now there was a point. What was your point again?
Big endian system.
Yes, it will not work in a big endian system because when you cast this, it would have chosen the wrong byte as the least significant byte and the wrong byte as the most significant byte. This works only because the Mbr, both the Mbr and the Intel architecture, they're both little endian specifications. If you have one as a big endian and the other one as a little endian, it's probably safest to access individual bytes and then use the shift operation to reconstitute the larger integer.
So if it was a big endian, it would be 55AA.
If this, yeah, exactly, it would have interpreted the same bit pattern, but only as 55AA in terms of the value of those 2 bytes. Yep.
Why didn't you use your method or whatever you want to call it that you made last time to do the conversion from
because I wanted to answer someone's question. Someone asked me, can't you just post a binary file so that we can run your binary and then figure out what the program is supposed to do? And the answer is the binary would have contained these strings too, which is a part of your homework assignment, to figure out how to use printf to output the hexadecimal numbers and stuff like that. Yes.
Wouldn't, if it was big endian, wouldn't you just do it backwards? Like, wouldn't you just specify?
You can specify the signature backwards. Yes. But what he said is correct too. He said that the integer would have been interpreted as 55AA, which is correct. You can change the signature to 55AA, also to match it, because in this case in terms of the signature, it's not an actual value, so there's no quote unquote wrong way to interpret it. There's no way to say that 55AA is the right way or the wrong way to interpret the signature. You're just looking at it for the bit pattern, but you're not looking at the value and try to compare it in terms of larger than or less than. You just want it equal.
So it wouldn't work the same. It wouldn't work the same way. It's just because it's oriented kind of backwards. Then I was thinking you could just specify the next. It doesn't work backwards. It's just oriented.
Now there is a way to do this, so that it is actually going to be endianness independent. Because what you can do is to define a const char unsigned char array, which has exactly 55AA, and then you do the same trick on this side, so that whatever the endianness is of the system, it will still be self-consistent. But that's like a lot of extra work. Are we doing okay so far with this program? It's okay so far? Now, I don't trust myself, so what I'll do is I'm gonna compile the program just to make sure that it is so far still okay. Mbr viewer .c, and we have a problem here. We have an unused variable Mbr size. Let's go ahead and change that. This is another place where the use of const may or may not work. Okay, let me show you what I mean by that. Okay.
Yeah. Mbr size isn't declared now. Oh.
No, I'm going to change it. I'm going to change Mbr underscore size to Mbr size. So the question is this now dependent on the order of the definitions? Okay. So first of all, I'm going to change Mbr underscore size, which was the macro name, to Mbr size. Okay. Now this looks okay to me because I did, introduce Mbr size before I refer to it. But this may or may not be okay because I'm using it to define the size of an array. And the size is, even though it's a constant, it is still defined up here as the value of a variable. Okay? Does anyone know for sure whether this will work or not?
I think it'll produce a warning.
It does.
I'm pretty sure it'll work in C++, but not C.
Well, even in C++, if you reverse the definition, it won't work. You have to extern it first in that. Well, you can't even extern it because if it's a local variable, there's no way to extern it.
I'm pretty sure if you do this in C, it will not work.
Okay, let's see. Yeah, you just took it. Maybe I should turn on pedantic. How do you spell it?
It's P-E-D.
P-A-N.
P-E-D.
P-E-D-A-N-T-I-C.
What does that mean? Pedantic?
It means know it all.
No, I meant like, what does it mean in code?
It's telling the compiler to get know it all.
Prickish. Meticulous. Depending on the spin, positive spin or negative spin, like electrons. Quarks.
It means making a great show of learning, I think, is technically.
Okay, so here we have a warning because it says here C94 bits below variable length array buff, and of course this is really quite interesting because it shows the history of the evolution of the C programming language, not being very self-consistent. Let me do one thing here. I'm just sick and tired of having to type all that stuff. This file called in the home folder called .vimrc is basically containing the commands that you want to run every time VI starts up. So if there's anything, any special configuration that you want to set up, you want to specify, this is a good place to specify it. It is also used for GVim, so if you want to use a particular font size or anything that is your own setup, that's also a good place to put it. All right, are we doing okay so far? So this is another reason why pound define sometimes is better, because when you use pound define, you won't run into that particular warning. Is there any way to override that warning?
Probably.
What did you put in your VIMRC? What did you?
I use syn on, which means syntax on, syntax highlighting on, and then set AI is auto indent. Yep. They're both really useful commands. You can also change your tab size and also the shift width. Those are good options to change too. Okay. Are we doing okay so far with the program? All right. So now that we have the program kind of done, even though we have a warning here, depending on how much you want to get rid of the warnings, we can actually change the program back to use macros, so that it won't give me that warning. So now is a good time to test it, and to test it, we'll use the file that I captured last time and post onto the website. So we'll go ahead and download mbr.bin into the folder where we have today's sample program. Switch back and then say mbr viewer, redirect from mbr.bin, and it says Mbr Signature confirmed, which is exactly what it's supposed to do. That's all that it is supposed to do. So now the question is, in terms of programming style, not for the correctness, just programming style, is it okay to do it this way or better to do it this way? Or is it better to do it the Perl way? The Perl way is to say, if you see something that is not supposed to happen, you say die if da 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 da. Die is basically the exit construct in the Perl program. So basically you're telling the program to terminate before hitting the end. Whenever you find something that is not recoverable, you just say stop here and go away. Okay? And I can do the same thing here. In other words, I can sprinkle my return throughout the entire program. But instead, personally, I like to do it like this, using the nested if conditional statement, so that every single time I check one thing, if it checks out, I go into the one portion of the conditional statement, and I do the same thing again, and then do the same thing again. The program does get more complicated as time goes on, because if you have a lot of stuff that you're checking, then you'll be like 20 levels into there'll be 20 levels of conditional statements. So it does make the program a little harder to read, but you can always abstract out the program so that so that every single time you have to deal with it, you only have 4 levels of embedding in your conditional statement. Then you turn it into a subroutine. You just call the subroutine to handle the other 16 levels of conditional statements. So programming style, I personally just like to do it this way, so I don't have to worry about exiting early inside a conditional statement. It's also a habit thing, because once you get into the habit, I think, for myself, once I get into the habit of sprinkling returns inside the conditional statement, I will probably, forget, and use it somewhere else, just for convenience. So that's why, I personally do not use it at all and sprinkle the return statements. Any questions, any comments about this? In C and C++, you have a throw and catch mechanism, which works better, because in that case, it actually does something that is much more meaningful than just a return statement.
But we don't have that in C.
No, we have something similar. We have set jump and long jump in C. You don't want to know that.
And we have airno too.
Huh?
The airno macro.
Yeah, we have the airno, which is also a very handy feature. Just tightening my shoelace before I fall on my face. All right, so moving on to the program. I hope this is not a waste of time, because many of you are done with the program already, and but I'm just kind of show you, little things that I think I picked up over the years. Okay, the next thing says, for each partition record of the partition table, I want to do something. Okay, just after reading that part, without even reading any further, I'm going to put the code here. Okay, this may be a good place to kind of spin off another subroutine. Okay, whether you want to spin off a subroutine at this point or earlier or later, depends on how much logic you want to read at the same point, and how comfortable you are with reading a program or reading a single subroutine that is kind of long. Okay, it also depends on how you debug your program. Since I just kind of debug the program, I did not feed it anything that is incorrect. I probably should have generated MBRs that are incorrect and make sure all the other branches are working too. If I did that, then even though the program may be a little bit complicated and long, I'm not really debugging all 20 or 40 lines at once. I'm always only dealing with the last 5 or 6 lines that I'm introducing in the program. So it depends on your comfort level a lot, whether when you want to spin off another program. This is a clean point to spin off too, because I don't have a whole lot of variables and parameters to pass into a subroutine. The only thing I have to pass to the subroutine is the unsigned char buffer. That's the only thing that the rest of the program relies on. The signature, it doesn't need it. Okay, the constants for the most, it doesn't even need the other constants. So this would be a good clean point to do further processing. So I would just go ahead and spin it off at this point. So I would just say process partition table, and then I'll just give it buff, which is the entire MBR buffer. Now this is actually not a good idea, because the rest of the program doesn't really need the entire MBR, does it? Okay, it just needs the partition table portion of it. So this is a good place to define another unsigned int, and we call that partition table offset, and we define it to be, was it 440?
Yeah.
Okay. So then we only give it that portion of the array, so that we don't have to add this offset every single time when we access individual items.
I believe there are another 6 bytes after that. It's 446, not 440.
Okay.
That's the beginning of it.
Let's double check. You're correct. It's 446. But this is where defining a constant comes in handy. Because then you can say, oh, but what is 440? Well, 440 is actually what I think or what I thought was the beginning of the partition table. Here you go. So this constant is not very useful. It's only used once, but it does tell me what it is. Okay, so it is still useful from that perspective. A good compiler can always optimize it out. Okay, a lot of compilers would actually optimize it out, because a compiler can figure out how you're using a particular variable or a const variable. If it finds that you don't need the address of the const variable, some compilers can optimize it so that the constant is actually put into this place here in place, or it is inlined. As a result, it is fast. It's just as fast as saying 446 in place of the reference to the const variable, and it does not use up any more space. So a lot of times, things that we think, well, maybe I should make the algorithm faster by doing this little trick and that little trick. You probably should not be doing that, because those are called local or peephole optimization, and the compiler can do a pretty good job of doing that. From our perspective, to make something faster, we choose a better algorithm. That's how we make things go faster. When you use bubble sort, it's really slow. But if you change to say quick sort or merge sort, it improves the complexity of the algorithm. So you're no longer nitpicking little things and making improvements of 2% or 0.5%. You're actually changing the order of the time complexity, which makes much more difference than the optimization like this type here. All right. So once we have that, we go back and then we define the subroutine. So we say void process partition table, and it expects const unsigned char above. Well, you shouldn't call it above, you should call it the partition table here. And then we continue the logic here. Okay? Yep.
Oh, I didn't have a question. I was stretching.
Okay, stretching. Okay.
Sorry.
That's all right. So now we move our notes here, just move it down to this portion. And according to the homework assignment, the first thing we want to do is to check the status byte. But before we do any, we go any further, maybe we should just set up a loop. So we say for I equals 0, I is less than 4, plus
Oh,
I.
I have a question about that loop.
Mhm.
Why did they make it in the C99 declaration that you can't have you can't declare a variable inside a for loop?
That's that's one difference between C and C++, because in C++ you can, but I think in C you cannot.
But why?
Is that right?
It
I mean,
bad?
doesn't.
Is it bad or something? Why would they take that?
I have no idea.
Oh.
In C++, you can also define a variable anywhere within a scope, and that's actually an end result of that. Okay, so over here, we'll go ahead and just print out the header, partition number, blah, on a single line. And you notice that in this case, I didn't say whether x should be base 10 or base 16 or base 8.
I thought it was supposed to be binary.
X should be replaced by literals 0 to 3, so you can use base 4 because it makes no difference. 0, 1, 2, and 3 are exactly 0 and 1, 2, and 3 for any base from base 4 and up. They are exactly the same. Okay, so we'll say printf partition is bootable pound.
I have a question.
And then
Why did? How come we're only printing partitions 1 through 4? I mean, you could have more partitions than that, but they'd just be logical.
Yes, but the logical partitions are not stored in the MBR. So to access your logical partitions, you have to access the, I think it's a GUID based partition table.
Oh, okay. Oh.
So you have to access the GPT in order to access your logical partitions. To your MBR, you have one logical partition, and that's it. So it sees the whole thing as one single partition. But when you go to the logical partition itself, then it has its own quote-unquote MBR. It's not a master boot record, but it has its own little header to contain additional information of all the partitions that is contained within the logical partition itself. Question?
Well, on my computer, my MBR, it has 2 partitions on it that are exactly the same.
Then you have 2 partitions that are, even the CHS, the starting point and the ending point.
All of it. Exactly the same.
Nothing says that you cannot have that. It's just unusual.
Okay.
Nothing says the partitions cannot overlap either. It's just a bad idea. Overlapping is a bad idea, but in your case, I have no idea why it is set up like that. Is it your virtual machine or is it your actual machine?
Actual MBR.
The actual MBR.
Laptop MBR.
That is strange. Is
You
it
can look at my MBR too. I sent it to you.
Okay.
It's in the files.
Okay. All right. So I just introduced this line here. I don't think I have to test the program, because it was working before, and this is relatively simple logic. But I do want to continue to read my own homework assignment here. And the next line says, we want to look at the status bit, the flag byte, to see whether the partition is bootable or not. And if it is not, we want to report this byte here. And the rest of it will also refer to a particular partition record, not the entire partition table. So maybe it is handy to have my little local variable to say this is the beginning of the partition record itself. We don't care where the partition table is. We only want to know where is the beginning of this partition record. So what I'll do is I'll just introduce another, unsigned char pointer, or in this case it has to be const2. we'll just call that the beginning of the entire partition table. And I also kind of violated one of my rules here. If it is a pointer, I typically use a lowercase p as a prefix to indicate this is a pointer. This is not actually a table. This is a pointer to a table. So here I would also use the same thing. This is a pointer to a partition record. And what should I put here next to the equal symbol? Okay, I times the size of a partition record. So we'll say partition record size plus p part tab. And then I'll go ahead and define unsigned partition record size to be 16. Okay. There are two ways to look at this. But some people will say, but the multiplication is truly unnecessary, because if I define p part rec, the pointer to a partition record outside here, then I can use the for loop to increment that by 16 bytes or 16 locations each time I go through the loop. That is true, but once again, we are talking about optimizations that can be done by the compiler. Believe it or not, some compilers can look at this code here and figure out that each time I'm only adding part rec size to the pointer itself, and be able to just add that much to the pointer instead of going through the multiplication. Yep.
I'm just curious as to logic. Why wouldn't you put the for loop back in your main and then have the process partition tab function just process each particular partition?
You could organize it that way too.
Yep. I have a question. Why are you using the pre-increment on I?
Doesn't matter whether it's pre-increment or post-increment, because we are not making use of the value of the expression itself.
Okay.
Yeah, you are. In the
Not-
line you're currently on.
You mean
the same
here?
Expression.
I'm not.
No.
That gets evaluated at its own point, so it doesn't matter when it gets changed. It would only matter if we were
Right.
potentially reading I
It's only
before
this.
changing it.
Exactly. I'm only interested in the side effect of plus plus I, which is increasing the value of I by 1. So whether it's pre-incrementing or post-incrementing makes no difference to me. You can use I++. Maybe that works just as well. All right. So then I can specify the logic here, or as you said, I can partition this into another subroutine to only process a partition record. That works as well. Okay, so it's entirely up to you guys to, of how to do it. You can say process partition record, and then give it a const unsigned. Oops, I get it all computed already. So now I can separate that logic into its own subroutine. That. So, yep, we can do it that way too. You can chop your program down to tiny little portions. It's just sometimes when you have too many functions, it gets harder to track down the code, because you have to follow one subroutine and then it calls another subroutine, it calls another subroutine. But when it's logical to do it, it's a good idea. All right. So what do we have to do here? We have to access the first byte. So here is another thing, whether it is necessary or not is entirely up to you. Because what I would do is I would still write down here and say the flag offset is 0. So if it is really 0, there's really nothing for me to do. But I want to document it. This is actually part of my self-documenting part of the program. Because if I just use whatever p part rec points to and check whether that value is what I want, then next time I look at my program 2 years later, I will have no idea what I'm actually doing unless I comment it. But this way, I have my program to be somewhat self-documenting. Yep.
But as a counter argument to that, in this case, I would argue that you wouldn't know whether your values were correct unless you were looking at a map of the partition table anyway. So wouldn't that kind of be its own documentation? Because I agree with what with the concept of that. I just personally I chose not to do anything like that because I realized I would have no idea if the values I put were right unless I had the Wikipedia page up anyway.
Also, is the MBR, how universal is that? Is that pretty universal across all?
Well, for this program, a lot of this stuff is not necessary because we know those are basically fixed constants. We are not, there's no way, these constants will change anymore because the whole thing about the MBR is obsoleted already. It's being replaced by, much better mechanisms of doing the same thing. But from the perspective of programming practice, this is good habits to have, just because, when you write the next program, maybe, when you first wrote the program for the first 5 years, nothing gets changed. But maybe after the 5th year, people started to change something about the standard, and now you have to go through your whole program and look for constants, and then have to keep changing those constants. But if you do it this way, yes, we may be doing something for nothing, there's no return at all. But one, it is not wrong to begin with, it's just a little bit more time consuming than otherwise. But two, if we need to change it in the future, we can change it easily. In other words, if the flag of a partition record gets changed to some other offset location later on, it will be an easy change for me because I only have one constant to change. So it's just based on how much change you want to go through in order to do it. Any other questions? Yep.
Could you instead of doing making buff a char, could you have made it the uint8 type?
Say again?
When we were reading in from the MBR, put it in buff was a char, was a char type, character type, character array type. Could we have just used uint8 type?
Yes. We could have just used that too. Yep. All right. So now we are finally getting to test the flags. Yep.
Do you have to do the casting then?
Yeah, I was wondering that too.
No, it's not necessary. Nope. But this will be consistent with everywhere that I use that I refer to what the buffer is pointing to. So every single time I do that, I make it explicit so that I know I'm looking at an 8-bit wide thing instead of whatever buff is pointing at.
But in this case, since you're only reading 8 bits, shouldn't it, as long as your integer width is at least 8 bits, it should read the identical. It should
That
read
is
the
correct.
same value.
Yes. All right. Well, we are almost running out of time. So now we have to check for the flag. We have 3 conditions. One is the partition is bootable. One is the partition is not bootable, and then the other one is it is an invalid byte. Now, when it's an invalid byte, I didn't say that you can just skip the rest of it. In other words, there's no special exit condition here, but there are 3 ways to proceed. So one way to do it in the C program is to use a switch statement. That's what I did. So you have one case which is bootable, and I always put a break right away. 0 and default. Now I know the breaks, in the last case is not necessary, but I always put a break anyway. It's just a habit to make sure that I put a break, because you can change the order. Can you change default to be first? You can, except in that case, default would take everything, because I think the order of the specification is important.
Yeah.
Yep. So I would do it this way, and then put in the printfs, as the messages, in here. But I think I'm running out of time, and this is another thing that that I use myself. I use my initial, just in case the program is also going to be used by other people, and I used to indicate, this is something that I want to continue to do next time, and I'll just say continue here. Next time. So this is a bookmark left for myself so that I know where to continue with the program, on Wednesday in this class.
When is our next program due?
The next program has no set due date yet because I have to walk through the program with you guys so that we all go through, manually at least how to go through an extension 2 file system. So we have to do the super block and all the other stuff. So for the most part, until I give you guys a due date, there's no set due date. It's just a good idea to kind of look ahead a little bit and try to figure out some of that stuff by yourself first. But I will walk through everything by hand. I won't give you the code to do it, but I'll go through everything by hand so that you can at least understand, okay, this is what needs to be done, and then you have to translate that into actual C code.
So if we're using ext3, we have to turn off journaling to do what you're talking about?
Extension 3 is backward compatible to extension 2. So the program should work on an extension 3 file system as well.